Myself, I am Keshan from CSC Section B. My topic is binomial distribution. Which of the following is most likely to be well modeled by a Poisson distribution? Number of trains arriving at Falmouth every hour, number of lottery winners each year that live in Brington, number of days between solar eclipse, number of days until a component fails. As the Poisson, number of trains arriving at Falmouth every hour, no supposed to arrive regularly on a timetable, not a random. Number of lottery winners each year that live in Warrington. Yes, it is number of random events in a fixed interval. Number of days between solar eclipse. No, solar eclipse are not random events, and this is a time between random events, not the number in some fixed interval. Number of days until a component fails. No random events, but this time until a random event, not the number of random events. Time between random events or time till first random event. If a Poisson process has a constant average rate v, the mean after a time t is lambda equals to vt. What is the probability distribution for the time to the first event? Exponential distribution. Poisson discrete distribution p of a number of events. Exponential continuous distribution p of time till first event. Number of trains arriving at Falmouth every hour. Number of lottery winners each year that live in Brington. Number of days between solar eclipse. Number of days until a component fails. Are the Poisson answers. Number of trains arriving at Falmouth every hour. No supposed to arrive regularly on a timetable, not at random. Number of lottery winners each year live in Brington. S is number of random events in fixed interval. Number of days between solar eclipse. No solar eclipse are not random events, and these between random events are not the number of some fixed interval. Number of days until a component fails. No random events, but this time until a random event, not the number of random events. Time between random events or time till first random event. If a Poisson process has a constant average rate v, the mean after a time t is lambda equals to vt. What is the probability distribution for the time to the first event? Exponential distribution. Poisson discrete distribution p of number of events. Exponential continuous distribution p of time till first event. Exponential distribution. The continuous random variable y has the exponential distribution with constant rate parameter v. If f of y equals to v occurrence time until the failure of a part, separation between randomly happening events. Assuming the probability of the events is constant in time, v equals to constant. Relation to Poisson distribution. If a Poisson distribution process has constant average rate v, the mean after a time t is lambda equals to vt. The probability of no occurrences in time t is p of k equals to 0, e power minus lambda into lambda power k by k factorial equals to e power minus lambda equals to e power minus vt. If f of t is the PDF for the first occurrence, then the probability of no occurrence is p of number of by t 1 minus p first occurrences has happened by t 1 solved by differentiating both sides with respect to t assuming constant v. On every average lightning kills 3 people each year in the UK. Lambda equals to 3, so the rate is v equals to 3 by. Assuming strikes occur randomly at any time during the year of v is constant. Time from today until the next fatality has PDF. Exponential distribution. A certain type of component can be purchased new or used. 50% of all new components last more than 5 years, but only 30% of used components last more than 15 years. If it possible that the lifetimes of new components are exponentially distributed? No. Exponential distribution. A certain type of component can be purchased new or used to 50% of all new components last more than 5 years, but only 30% of used components last more than 5 years. It is possible that the lifetimes of new components are exponentially distributed. Exponential distribution models time between independent randomly occurring events where frequency of events is independent of time. Example, probability of failing in the first 5 years has to be same as the probability of failing in any other period of 5 years. No memory property. The observed lifetimes imply that instead the failure rate must increase with time, not exponential. Example, reliability. The time till failure of an electronic component has the exponential distribution, and it is known as that 10% of components have failed by 1000 hours. What is the probability that a component is still working after 500 hours, 5000 hours? Find the mean and standard deviation. Is it exponential? Which of the following random variables is best modeled by an exponential distribution? The distribution between defects in an optical fiber, the number of days between someone winning the national lottery, the number of fuses that blow in the UK today, the hours of sunshine is Brington this week, assuming of an average 7.2 hours per day. Is it exponential? Which of the following random variables is best modeled by an exponential? The distance between defects in an optical fiber is continuous distribution, that is the separation between independent random events, the location of the defects, the number of days between someone winning the national lottery. No, continuous if you allow fractional days, but draws happen regularly on a schedule. The number of fuses that blow in the UK today. No, this is a discrete distribution. The number of events is a Poisson distribution. Exponential is the distribution of times between events. The hours of sunshine is Brinton this week, assuming an average of 7.2 hours per day. No, this is a continuous variable, but not the times between independent random events. Normal distribution. The continuous random variable x has the normal distribution if the PDF is f of x equals to 1 by under root 2 by sigma square. Note, the distribution is also sometimes called a Gaussian distribution. X lies between mu 1.96 and mu plus 1.96 with probability of 96. X lies within two standard deviations of the mean approximately 95% of the time. If x has a normal distribution with mean and variance sigma square, right, occurrence of the normal distribution, quite a few variables. Example, distribution of sizes, measurement errors, detector noise, bell-shaped histogram, sample means and totals. See later. Central limit theorem. X approximation is to several other distributions. See later. And occurrences between x lies between mu and the x lies within two standard deviation of the mean approximately 95% of the time. If x has a normal distribution with mean, mu and variance sigma square. Occurrence of the normal distribution, quite a few variable. Example, distributions of sizes, measurement errors, detector noise, bell-shaped histogram, samples means and totals. See later. Central limit theorem. Approximation to several other distributions. See later. Continuous distribution of the, that is a separation between independent random variable events, the number of days between someone winning the national lottery. And thank you.